Okay, hello student. This is Darasa Online. My name is Edi Kamshana. I'm teaching advanced mathematics. And today we are going to review the topic of vectors. And the subtopic that we are going to review the questions are, we have the dot product, and two, we have the cross product. Join with me till the end of this presentation. Welcome. Now, my dear students, here we have the review questions for dot product. We are going to start with the first question. The first question says, given vector A is equal to 3i minus 2j plus k, and the vector B is 6i plus 7j minus 4k, and vector C is equal to I plus 3j plus 2k. Now evaluate the following. Now A dot C, and B is B dot C, and C, that is A dot B. Now let us start with the A. That is, of course, the subtopic is dot product. That is dot product review question. Review questions. And of course, we are starting with the question number 1. That is A. We have been given vector A, that is A, is equal to 3i minus 2j plus k, while vector B, that is equal to 6i plus 7j minus 4k, and vector C, that is vector C is equal to I plus 3j plus 2k. Now we are supposed to find the product between vector A and C, that is A dot C. Now A dot C, this is the same as taking vector A dot vector C. So this is equal to vector A is given by 3i minus 2j plus k dot vector B, that vector C, that is I plus 3j plus 2k. Now it is very simple, because here we are just taking the vectors of the same unity, that is 3 times 1, because here we have 1, so it's 3 times 1. We are going to have, it is 3. Then followed by, we have negative 2 times 3, that is negative 6. And the last one we have, that is 1 times 2. So 1 times 2, that is 2. So we have 3 minus 6 plus 2. This is equal to 5 minus 6, which is equal to negative 1. Therefore, in this case, vector A dot vector C, this is equal to negative 1. That is A. Then B needs to find vector B dot vector C. So that is B. We have question number 1, B needs to find vector B dot vector C, which is equal to, so vector B, we have 6i plus 7j minus 4k. So this vector dot, the second vector is C. So vector C is I plus 3j plus 2k. So again, we just take 6i times I. Of course, that is 6 times 1. So which is equal to 6, because 6 times 1, that is 60. So again, we proceed with the j. So we have 7 times 3. Now this one is equal to 21. Then we have, for k, we have negative 4 times 2, which is equal to negative 80. So here we can add and subtract. Of course, you have 60 plus 21, that is 27 minus 8. So this one is equal to 19. Therefore, vector B dot C, this is equal to 19. Then again, students, let us proceed with C. For C, we are supposed to find vector A dot vector B. So for C, that is A dot B. Just take vector A dot vector B, which is equal to, so we have vector A, which is 3i, that is 3i minus 2j plus k dot, then followed by vector B, which is 6i plus 7j minus 4k. So again, starting with the I, we have 3 times 60. This is equal to 18. Then followed by j. For j, we have negative 2 times 7. That is negative 14. Then the last unit is k. So of course here we have 1 times negative 4. That is negative 4. So we have 18 minus. Here we have negative 14 minus 4, which is equal to 18. So the answer here is equal to 0. Therefore, vector A dot vector B, this is equal to 0. Now, something which is very important in dot product. So here note, that is I dot I. This is the same as J dot J, which is the same as K dot K, which is equal to 1. The answer is equal to 1. So when we are doing dot product, remember this property is very important. Now, my dear students, let us proceed with the second review question. And this time, we were asked to find the angle between the vectors A and B. We have 2 vectors, and we are supposed to find the angle between the 2 vectors. So question number 2, that is 2 given. We have been given vector A, that is vector A is equal to 3i minus j minus 2k. While vector B, this is equal to, we have I plus 2j minus 3k. So we are asked to find the angle between the 2 vectors. Now for 2 vectors, A dot B, this is equal to equal to magnitude of vector A dot magnitude of vector B times cosine of angle theta. So the dot product between two vectors A and B is equal to product of magnitude of vector A dot magnitude of vector B cos theta. So let us make cos theta the subject. So we are going to have cos theta is equal to A dot B over magnitude of vector A times magnitude of vector B. So since we are looking for angle theta, we are going to have theta is equal to cos inverse of vector A dot vector B over magnitude of A dot magnitude of vector B. So first we are supposed to start with A dot B. So here starting with A dot B. So A dot B is equal to, just take vector A, we have 3I minus J minus 2K dot B, which is I plus 2J minus 3K. So starting with the I. So again we have 3 times 1, that is 3. Remember I times I is equal to 1. Therefore just write 3. So for J we have negative 1 times 2, which is negative 2. So again remember J times J is equal to 1. So the last unit is K. We have negative 2 times negative 3. That is positive 6. In this case, we have 9 minus 2, which is equal to 7. Therefore, A dot B is equal to 7. So again, we are supposed to find the magnitude of vector A and magnitude of vector B. So starting with magnitude of vector A, this is equal to square root of, so we have, for vector A, we have that is 3 squared plus negative 1 squared plus negative 2 squared. In this case, we are going to have, that is 9 plus 1 plus 4. So here we are going to have the square root of 14. So this is the magnitude of vector A. So we proceed with magnitude of vector B. So B again is equal to square root of, so this time we use units of vector B. So we have 1 squared plus 2 squared minus 3, that is squared. So that is plus negative 3 squared. So again, this is equal to 1 plus 4 plus 9. So again, the magnitude of vector B is equal to square root of 14. Now, students, we have vector A dot vector B, which is equal to 7. But again, we have the magnitude of vector A and the magnitude of vector B. So we have to apply our general formula, which is equal to that is theta is equal to cos inverse of A dot B over magnitude of A times magnitude of B. So this is equal to cos inverse of, remember, A dot B is equal to 7. So this one is 7 over, then we have magnitude of B, which is equal to square root, magnitude of A is equal to square root of 14. So here we have square root of 14 times square root of 14, which is the magnitude of vector B. So we have cos inverse of 7 over, so here we have square root of 14 times square root of 14, which is equal to 14. So this is the same as cos inverse of, that is 7 over 14, because this is the same as a half. So you can take your calculator and find the cos inverse of a half, which is equal to 60 degrees. Therefore, angle theta, therefore the angle between the two vectors, that is vector A and vector B, is equal to 60 degrees. Dear students, that is how to find the angle between two vectors. Now let us proceed with review question number 3. This time we have unknown. This time we have unknown. That is find mu, given that the vectors A is equal to I minus mu j minus 3k. But again, vector B, this is equal to 2i plus j minus 4 mu k. These vectors are orthogonal vectors. What does this mean? Orthogonal vectors are the vectors which are perpendicular. They make a right angle. So the dot product between the two vectors which are orthogonal or which are perpendicular is equal to 0. Now let us apply this concept of orthogonal vectors to find the unknown. So review question number 3. We have been given vector A is equal to 2i, that is I, minus mu j minus 3k, while vector B is equal to 2i plus j minus 4 mu k. They said these vectors are orthogonal. That means they make a right angle. So the dot product between the two vectors which are orthogonal is equal to 0. That is by definition. That's the meaning of orthogonal. So orthogonal vectors means they are the vectors which are perpendicular to each other. They make a right angle. And the dot product between the two vectors is equal to 0. So vector A is I, that is I, minus mu j minus 3k. Now, that is dot vector B, we have 2i plus j minus 4 mu k. This is equal to 0. So starting with the I, we have, that is 1 times 2, because this is 2. Then for j, we have negative mu times 1, that is minus mu. And for k, we have negative 3 times negative 4 mu, that is plus 12 mu. This one is equal to 0. So we have 2, this is negative mu plus 12 mu. This is going to be a positive 11 mu, which is equal to 0. So we shift 2 in our right hand side. So we are going to remain with 11 mu is equal to negative 2. So here we just divide by 11 by 11. So mu is equal to negative 2 over 11. So that is how to find the unknown from the two vectors which are orthogonal. So, my dear student, let us proceed with review question number 4. Review question number 4 is about the area of a parallelogram. The question says, find the area of a parallelogram whose adjacent sides are I minus 2j plus 3k and 2i plus j minus 4k. So again, we have two vectors. So that is number 4. Can say let vector A is equal to I minus 2j plus 3k. And again, let vector B is equal to the second vector, that is 2i. You have 2i plus j minus 4k. We need to find the area of the parallelogram. So since we have the sides, so the area of a parallelogram, that is area, is given by the magnitude of vector A dot vector B. So that is the same as taking the magnitude between vector A and that is dot vector B. So this is equal to, so we have vector A, that is I minus 2j plus 3k. So this one dot the second vector, which is 2i plus j minus 4k. So why are we using the absolute value? To avoid a negative answer. So area always is positive. So we just avoid getting the negative area. So this one is equal to, so starting with the I, we have again, that is 1 times 2, that is 2. So for j, that is negative 2 times 1, that is minus 2. And for k, we have 3 times negative 4 is negative 12. So this one is equal to magnitude of, so this is 2, the same as 2 minus 14. So which is equal to the magnitude of negative 12. So the magnitude of negative 12, this is equal to positive 12. Therefore, area is equal to 12 squared units. So that is how to find the area of a parallelogram if we have given the adjacent sides as the vectors. So students, we proceed with the review question number 5, and this time we are going to find the work done. That is the application of the dot product. So review question number 5 says, find the work done in moving an object from vector A, that is I, minus 2j plus 3k, to vector B, which is equal to negative 2i minus j, if the force field is F is equal to 2i plus 2j plus 3k. So we are going to find the work done. I said that is the application of a dot product. So that is the review question number 5. Now given, we have vector A, that is vector A is equal to I minus 2j plus 3k, while vector B is equal to negative 2i minus j. This implies that k was equal to 0, that is 0k. Okay? And we have been given the force, which is equal to 2i plus 2j plus 3k. What is missing? The work done. We need to find the work done. That is work done. So by definition, work done, that is work done, is equal to force dot perpendicular distance times distance between the two vectors. So we need to find the distance between two vectors so that we dot with the force field so that to get the work done. So here, distance that is between vector A and B. But what does this mean? This is the same as taking vector B minus vector A. That is the difference between vector B and vector A. So vector B, that is negative 2i minus j plus 0k minus vector A, we have I minus 2j plus 3k. That is how to find the distance between vector A and vector B. So for I, we have negative 2i minus I. So it is negative 2i minus I, that is minus 3i. For j, we have negative j minus 2j, minus negative 2j. So that is negative minus minus, we are going to have that is positive j. That is positive j. So for k, we have 0 minus 3k. So that is minus 3k. So now we have the distance. So the distance between the two vectors is equal to negative 3i plus j minus 3k. Now we can find the work done, because we said work done is equal to force times this, that is not distance between the two vectors. So this one is equal to, our force is 2i, we have 2i plus 2j plus 3k dot the distance is negative 3i plus j minus 3k. So again, starting with the I, here we have 2i dot 3i, that is negative 6c, followed by j. J, we have 2 times 1, that is 2. Then we have k, 3 dot 3, negative 3, that is negative 9. So this is equal to, we have negative 6 and negative 9, that is negative 15 plus 2. In this case, we have negative 15 plus 2. So this one is equal to negative 13. But remember to apply the absolute value to avoid the negative answer. So here we are going to have 13. Now this will be units of work done. So 13 units of work done. So my dear students, that is how to find the work done between the given two vectors. So let us proceed with another subtopic, that is review questions for cross product. This time we have cross product, that is the second subtopic. So we proceed with the review questions for cross product. So this is the second subtopic that we are going to review the questions. And of course here we have some questions to review. The first question, given vector A is equal to 3i minus 2j plus k, while vector B is equal to 6i plus 7j minus 4k. Evaluate A cross B. This time we have a cross product between the two vectors. It differs from dot product. So, given we have two vectors, that is vector A is equal to 3i minus 2j plus k, while vector B is equal to 6i plus 7j minus 4k. We are supposed to find vector A cross vector B. So by definition, the cross product between the two vectors, this is the same as the determinant of a 3 by 3 matrix, but the first row is replaced by units I, j, and k. Then the second row, that is vector A. So vector A, we have 3, we have negative 2, then we have 1. Then again, the last row, that is row number 3, that is vector B. So vector B, we have 6, we have 7, and we have negative 4. So here we just find the determinant between the two vectors. But the first row, we just write units A, I, J, and K. So that is equal to, starting with the I, here we have I, is the same as the determinant of 2 by 2 matrix, that is negative 2, 1, 7, and negative 4. Then followed by J, but here of course we apply negative sign, that is J, determinant of a 2 by 2 matrix, that is 3, 1, 6, and negative 4. And the last unit, that is K, so plus K. This time we have, that is 3, negative 2, we have 6, and 7. So now we are going to have I, then we take negative 2 times negative 4, that is positive 80, minus, so we have 7 times 1, that is 7. So minus J, this time we have 3 times negative 4, that is negative 12, minus 6 times 1, that is 6c. Then plus 4k, we have 3 times 7, that is 21, minus, then we have 6 times negative 2, that is negative 12, it will be plus 12. So this one is equal to, so here we have 8 minus 7, that is 1 times I, that is I. Then that will be negative times, that is we have negative 12 plus minus negative 6, that is negative 18 times negative 1, that is positive 18j. So for k, we have 21 plus 12, that is 33k. So that is how to find the cross product between the two vectors. Students, we proceed with the second review question. And this time again, we have two vectors, which represent the sides of a triangle. So find the area of a triangle. So this is application of a cross product. Let us see how we can find the area of a triangle. So that is review question 2. We have two vectors. That is vector A is given by 2i, 3j minus k. And the vector B is given by I plus 2j plus k. So we need to find the area of a triangle. So remember, my dear student, area of a triangle, this is equal to a half times the cross product between the two vectors, that is A and B. But make sure at the end your answer is positive. Now this is equal to a half. So remember, we are starting with the units I, j, and k. That is I, j, and k. Then followed by vector A, which is 2, 3, and negative 1. Then the last row, that is vector B. We have 1, we have 2, and we have 1. So this is equal to a half times. So starting with I. So here I times, that is the determinant of a 2 by 2 matrix. We have 3, negative 1, 2, and 1, followed by j. But remember, for j, we put negative. So a 2 by 2 matrix that belongs to j, we have 2, negative 1, 1, and 1. And the last one, we have k. Then a 2 by 2 matrix which belongs to k, we have 2, 3, 1, and 2. So here we are going to have a half bracket of, so we have I times, here we have 3 times 1, that is 3, minus, we have 2 times the negative 1, that's negative 2, that is plus 2. Then minus j, this time we have 2 times 1, that is 2, minus 1 times negative 1, again that is 1. Then plus k, now for k, we have 2 times 2, that is 4, then minus, so we have 1 times 3, that is 3. So in this case, we are going to have the area is equal to a half bracket of, so for I, that is 3 plus 2, that is 5. So we have 5, 5i, and then followed by j. For j, we have 2 plus 1, that is 3. So negative 3j. Then we have k. For k, we have 4 minus 3, that is 1 times k. Then we have k. So we can open up the bracket. In this case, of course, here we just find the absolute. Just find the absolute. Or we call it just the modulus. We find the modulus of these vectors. So this one is equal to a half, then times square root of, we have 5 squared, then plus negative 3 squared, then plus 1 squared. So we are going to have, that is a half, then square root of, that is 25, plus 9, plus 1. So this is equal to a half. So we have 25, that is plus 9 plus 1, that is 35, will be square root of 35. So this is the same as square root of 35 over 2. So that is the area. So it will be a squared units. So this is to find the area of a triangle. So my dear students, in this part of presentation, we have seen the review questions concerning to a dot product, but again, the cross product. That was the review questions on the topic of vectors. Till next time, don't miss this lesson of advanced mathematics. Welcome.